Simultaneous equations. The learning objectives. By the end of this section, you should be able to use elimination to solve simultaneous equations, balance the coefficients of simultaneous equations, use substitution to solve simultaneous equations, and solve problems involving simultaneous equations. Right, here we have an equation, 2x plus 3y equals 13. This equation has two variables, x and y. We cannot solve it using our normal methods of solving equations. We need to have two equations containing the variables and solve them simultaneously at the same time. Two of the methods we can use are elimination and substitution. Simultaneous equations using elimination. Solve simultaneously x plus 3y equals 13 and x minus y equals 5. To solve these equations, we need to eliminate one of the variables. Get rid of either the x or get rid of the y. To start, we're going to number the equations. So here we can say the top one is equation 1 or line 1, the next one is line 2 or equation 2. Identify if either of the variables have the same coefficient. So both the x terms here have a coefficient of 1. So we've got 1x plus 3y and 1x minus y. So the coefficients of x are the same. If the signs are the same, subtract them. If the signs are different, add them. So the coefficient of x1 here is plus. So plus 1x in both lines. So the signs are the same. So the signs are the same here, so we subtract them to eliminate the x terms. We annotate on the left of the calculation what we're doing. This notation here means line 1 minus line 2. So x minus x gives us 0. 3y minus minus y gives us 4y. And 13 minus 5 gives us 8. So we now have a new equation, so we number it. Now equation 3. We solve this equation as normal, just to find the value of y. It's only got one variable. So divide both sides by 4, and we end up with y equals 2. So we substitute the known value for y into any of the equations to find x. Quite often people get to this stage and they think they've solved it, forgetting that we have to find both the value of both of the variables. So we can either use line 1 or 2 and substitute that y equals 2 into it. So here we've substituted 2 into line 2, which gives us x minus 2 equals 5. Now we solve this equation to find the value of x. Add 2 to both sides, gives us x equals 7. Remember, when we answer a simultaneous equation, we need the value of both variables. So always end it like that, x equals 7, y equals 2. To check, we could substitute the values into the original equation and see if they work. So if we put x equals 7 and y equals 2 into either the first or second equation, it should come up with the answer that's there. So solve simultaneously. 3x minus 2y equals 16. And 2x plus 2y equals 14. Again, to solve these equations, we need to eliminate one of the variables. Either get rid of both x's from both lines or get rid of both y's. So we're going to start by numbering it as we do equation 1 and 2. Identify if either of the variables have the same coefficient. In these two lines, both the y terms have a coefficient of 2. If the signs are the same, we subtract them. If the signs are different, we add them. So the signs are different here. We've got minus 2y and plus 2y. So we add them to eliminate the y terms. And I say on the left of the calculation what you're doing we've got line 1 plus line 2. So 3x plus 2x gives us 5x, minus 2y plus 2y, 0, 16 plus 14 gives us 30. Again, we have a new equation, so we're going to number it. This is equation 3. And now we solve this to find the value of x. Divide both sides by 5, and we get a value of x as x equals 6. So we know the value of x, so we're going to substitute the known value of x into any of the equations to find y. So again, we could substitute it into line 1 or line 2, and as you get more experience, you'll see which one is probably going to be easier to work it into. So we're going to substitute x equals 6, so we have 3 times 6 minus 2y equals 16. We solve this equation to find the value of y. So we have 18 minus 2y equals 16. That's combining the 3 times 6. Now we go minus 18 from both sides. So we have minus 2y equals minus 2. Divide both sides by minus 2. And we have y equals 1. Remember, when we write our answer, we put the two values, x equals 6 and y equals 1. Again, if you wanted to check that you had the right answer, you can substitute both of these values into either line 1 or line 2 and see if they did work. So here's some simultaneous equations. Take your time with them. Biggest thing with this is people get confused with the negative signs. If I'm minusing a minus, so think about it. Think about what you're doing. Work through them slowly. The numbering of the calculations and the annotating on the left what it is you're actually doing. Students, after they've done the first two, generally go, I'm not bothered with this. If you do that, you are more likely to make mistakes. So pause the video now, work through the questions. Once you've got the answers, come back, play the video, and we'll check your answers. Right, so question 1, x equals 8, y equals 5. Question 2, x equals 3, y equals 4. Question 3, x equals 9, y equals 4. Question 4, x equals minus 2, y equals 4. Question 5, x equals 3, y equals minus 5. Question 6, x equals 8, y equals 0. For question 7, x equals 1 over 2, y equals 3. For question 8, x equals 1 over 3, y equals 10. For question 9, x equals 2, y equals minus 3. Question 4, x equals 5, y equals 3. Question 11, x equals 5 over 2, y equals minus 3 over 2. Finally, for question 12, x equals 12, y equals 2. If I've got any of them wrong, look back through your working out, see if you can identify where you made your mistakes, and once you've done that, then move on. So, solve simultaneously 4x minus 2y equals 2, and 2x plus 3y equals 9. As before, we're going to start by numbering the equations, equation 1 and equation 2. And to solve these, we need to eliminate either both of the x's or both of the y's. This time, neither of the pair of values have the same coefficient. So we multiply one or both of the lines to balance either the x or the y coefficient. So what you look at both of the y's, so what's the lowest common multiple of them? Or you look at both the x's, what's the lowest common multiple of them both? and choose either the x or the y to balance the coefficient, so to make the coefficient of one of those terms the same. If we multiply equation 2 by 2, both of the x terms will be 4x. So we multiply every term in equation 2, including the answer, by 2. Quite often people forget to multiply the answer as well. So we've annotated on the left, line 2 times 2. So 2x times 2 gives us 4x. 3y times 2 gives us 6y. And 9 times 2 gives us 18. Again, we have a new equation, so we're going to number it. This is equation 3. We're going to rewrite equation 1 under equation 3. You don't have to do it, but if we've got two equations we're working with close together, it does make it easier. There we go, and you may have chose to put that one on top, that one on bottom. As you get more experience, you'll see that there probably is an easier way of doing it. But for now, if you just stick with a system and work through it, and as you get more experience, you'll adapt it slightly. So the x coefficients are now balanced, so we can eliminate them, same as we did before. If the signs are the same, we subtract them. If the signs are different, we add them. So the signs are the same, they're both plus 4x, so we subtract them to eliminate both of the x terms. So we've annotated on the left again, line 3 minus line 1. So 4x minus 4x means the x terms have been eliminated, they've gone. 6y minus minus 2y. Again, this is where people get confused. Now, 6y minus 2y, oh, that's 4y, but we've got to look at this. This is 6y minus minus 2y. 8y. Again, don't forget to do the answer. 18 minus 2 gives us 16. This is a new equation, so we're going to number it again. So this is now equation 4. And now we solve this. Find the value of y. Divide both sides by 8, gives the value of y as y equals 2. Same as we did before, we're going to substitute the known value for y in any of the equations to find x. So here we've got equation 1, 2, or 3 that we could use. And again, we're going to look at which is the easiest one to put into. So we're going to substitute y equals 2 into 4x minus 2 times 2 equals 2. So we substitute it into equation 1. We solve the equation to find the value of x. So 4x minus 4 equals 2. We're going to add 4 to both sides. So 4x equals 6. Divide both sides by 4. X equals 6 over 4 or 3 over 2. Remember, don't expect your answers to always be nice integers or to be positive. They can be anything at all. So we have a final answer of x equals 3 over 2 and y equals 2. Again, as with any of the simultaneous equations, we could check that if our answer is correct by substituting the values into the original equation to see if they work. And it says there, don't expect your answers to always be integers. They can be fractions, they can be negative, they can be anything. So here's another set of questions. What I'd like you to do is to work through them, same as you did before. Take your time. It is worth doing an extra bit of numbering the equations, annotating on the left what you're doing. As these get more and more complex, if we do that, we're less likely to get make mistakes. And if you get to the end, sometimes you get a feeling, you go, right, I'm not sure if that's correct. If it is, substitute it in. If it works, it's correct. I'd like you to answer the questions. Once you've got answers, come back. So hopefully not too difficult. Question 1. We've got x equals 1 over 2 and y equals minus 3 over 4. Question 2. X equals 4 and y equals minus 3. Question 3. x equals 1, y equals 7. For question 4, x equals 2, y equals 5. For question 5, x equals 2 over 3 and y equals 3 over 4. Question 6, x equals -1, y equals 5. Question 7, x equals 5, y equals -1. 8, x equals 4, y equals 2. Question 9, x equals 3, y equals 1. Question 10, x equals 8, y equals 1 over 2. Question 11, x equals 2, y equals 1. Finally, for question 12, we have x equals -2 and y equals 4. So again, as I say for all the videos, if you have made a mistake, look back at your working out. If you can see obviously where you've made a mistake, that's all well and good, you can learn from it. If you can't really see it, work back through it until you can get to the right answer before we move on. Right, simultaneous equations, substitution. So another method we can use to solve simultaneous equations. So solve simultaneously. 3x plus 4y equals 1 and y equals 2x. Now we're going to start by numbering off the equations. So we've got equation 1 and equation 2. In equation 2, we are given the value of y in terms of x. So I know what y is worth. It's worth 2x plus 4 plus 3. Sorry. We're going to rewrite equation 1 and we're going to substitute 2x plus 3 for the y. It's important we use brackets here because this is where we can get slightly confused. So what people sometimes have a tendency to do is just forget about that 4 and just substitute y equals 2x plus 3. So it's important that we've got that there. So that's substituted into equation 1. We're going to expand the brackets to start with. We end up with this. Collect like terms. So we now have a new equation. This is equation 3. And we're going to solve this, as we would for any linear equation, to find the value of x. -12 from both sides. Divide both sides by 11. X equals -1. So there is a lot of stages of working out for this one. We're going to substitute that known value for x into any of the equations, same as we've done before. So here we've substituted into line 2 and it's given us a final equation of y equals -2 plus 3. So we're going to solve the equation to find the value of y. Y equals 1. So our final, we end it by writing x equals -1 and y equals 1. Solve simultaneously 4x plus 3y equals 10 and 2x plus y equals 6. Label our equations 1 and 2. This question could be solved using either substitution or elimination. A lot of you looking at this would go, I'm just going to go for elimination on this, and I probably would myself. However, what we're practicing here is technique of substitution, so it's important we stick with that and get good and confident at both methods. Rearrange equation 2 into the form y equals. So we've got y equals 6 minus 2x. Now we have y in terms of x, so we can substitute this into equation 1. Again, some people would say, well, I probably would have been more inclined to do it to equation 2. Remember, what we're doing here, we're practicing a technique so we can get confident with it. Expand the brackets, like terms. Now we have a new equation. Now we're going to solve this equation to find the value of x. So minus 18 from both sides. So we have minus 2x equals minus 8. Divide both sides by minus 2. and we end up with x equals 4. So we substitute the known value of x into any of the equations. So substitute x equals 4 into line 2, and we end up with 8 plus y equals 6. So we solve this equation to find the value of y. Minus 8 from both sides, y equals minus 2. Final answer, x equals 4 and y equals minus 2. So here's some questions, and what I want you to do is using substitution. Even if you can see it, elimination would probably work on this, and in some cases you can use either or, but this is specifically practicing using the method of substitution. So as before, pause the video, work through these. Once you've got an answer, come back and we check them. Question 1, x equals 8, y equals 5. For question 2, x equals 3, y equals 4. Question 3, x equals 9 and y equals 4. For question 4, x equals 5, y equals 3. Question 5, x equals 7, y equals 3. Question 6, x equals 4, y equals 11. Question 7, x equals 5, y equals 3. Question 8, x equals 1 over 3, y equals 10. Question 9, x equals 1 over 2, y equals 3. Question 10, x equals 3, y equals 2. Question 11, x equals 5, y equals 0. Finally, for question 12, you have x equals 6 and y equals 2. As I always say, if you've got anything wrong, look back over your working out. If you can see the obvious mistake you've made, that's all well and good. If you can't really work that out, you're not sure, work through it again until we get these questions right. Once you've done that, then move on. So here's just the last 3 questions, and they're just problem solving. What we need to know is these involve simultaneous equations. So pause the video, work through them, and then come back and check your answers. Question 1, £1.83. One chew costs 13p and one lolly costs 24p. Question 2, we've got £3.72. A first class stamp was 38p and a second class stamp was 26p. And finally, for question 3, we have x equals 3 and y equals 4. The area of the triangle is 30 centimetres squared and the area of the rectangle is 216 meters squared. So hopefully not too much problems there. It is important that you fully understand everything before we move on. So if there's anything there you struggle with, go back over the video, go through the working again until you've got it firmly in your head and you're actually confident with it.